This tutorial will show you how to add Prefab's powerful tooling to your Rails app. We'll set up Prefab, show off dynamic log levels, targeted log levels, feature flags and user targeting, and wrap it up with some live config and introspection. We'll build on a new Rails app using Tailwind as our CSS framework. All code will be linked in the video description. Installing Prefab is easy. We add Prefab Cloud Ruby to our gem file and then bundle install. Next, we modify application RB to set up our Prefab client and to wrap our Rails loggers to give us control. We assign the client as a global for easy use throughout our app. Because Rails uses Puma out of the box and Puma is a forking web server, we need to do the same thing in our on-worker boot. Finally, we need to get an API key from Prefab. We set up a new team and we create an SDK API key for our development environment. We'll copy it as an envar. We paste it into our terminal and restart our server. When we refresh localhost now, we see no logging output. That's because Prefab has wrapped our loggers and the default level is worn. Looking at a diff, we can see that we added the gem to our gem file. We've got some dependencies that came along for the ride. We set up our client and wrapped the loggers in application.rb, and then we did the same in our Puma config. That's all it takes. The first Prefab tool we'll look at is dynamic log levels. We'll add a home controller with 4 different log statements, starting from debug and going up to error in increasing level of severity. We'll add a view with some content for this controller action, and then we'll map this controller action to the root of our app. When we reload our Rails server, you'll note that we see our new content and only see the worn and error output. That's because Prefab's default log level is worn, but we can adjust this in the UI. Because Prefab has wrapped our logger, it knows about where our logging is coming from, and we can see that our home controller index action is represented here. We could override the log level right here on the index, but for demonstration purposes, let's do it on the root instead. We'll set the level to debug. Now when we refresh our page, we get the error and the warn, but also the debug and info output. Because Rails development mode logs at the info and debug level as well, you'll notice that your familiar log lines are back. Prefab allows you to do more than just change the levels on the fly. You can also do targeted log levels. Let's imagine we get a report of a bug that only happens on mobile, so we want to turn on more verbose logging on mobile requests. In our home controller, we'll add some code to give Prefab context for the current request. In and around action, we call Prefab with context and pass in our context. This is only live for the lifecycle of the request. Prefab context currently only shows whether the device is a mobile device. Mobile is implemented as, does the user agent match one of these strings? To demonstrate targeted logging, let's set our default level back to error. When we refresh the page a few times, we'll note that we're only seeing the error output. Great. Now let's dial in with some targeted logging. We'll add a targeting rule to use the debug level of logging when device.mobile is true. Now we'll save. As expected, reloading our desktop view continues to only show the error logging. But what if we tried this on a mobile device? We'll pull up our iPhone simulator. We'll refresh the page a few times. Sure enough, on a mobile device, we're getting all the way down to the debug level of verbosity. In just a short time, we've given ourselves powerful tooling to dig deeper into our logs to get exactly the detail we need. To the delight and terror of developers, most apps have users. We'll make Prefab aware of our users so that we can do additional targeting with feature flags and log levels. For this demo app, we'll skip the boring user authentication and user modeling bits and just fake some example users. We'll add info about the current user to our existing Prefab context. Next, we'll personalize the view to greet the user, and then add some content to switch between our example users. When we test out our new UI, we'll see that we're initially signed in as Tony, but we can swap between other users. We're currently showing a GDPR cookie acceptance banner to every user. Let's imagine that our lawyer tells us that we don't have to show this to users in the US. Jeff is in the US, so we could omit this banner for him. Let's use a feature flag to declutter our UI. Back in our index view, we'll wrap the GDPR code with a prefab enabled check. Because an enabled check returns false by default, we can't just ship this to production as is. It wouldn't show up for Tony or Joan. We'll create the flag in the prefab UI. Going over to feature flags, we'll add a new flag. We'll name it GDPR.banner as we see in the code. We'll set the default value to true so that it shows up for both development and production. Back in the development rules, we'll add a new rule that says that we want to return false when the property user.country matches US. We save and then publish. We see that refreshing the page now shows Joan the acceptance banner. That's great since she's from France. Tony also sees it since he's from the UK, but Jeff in the US no longer sees the banner. Awesome. We can also use this user context with our logging for even deeper targeting. We'll add one last feature to help us better understand how Prefab works in our app and to demonstrate live config. First, we add a new partial to render out our resolved prefab values for our application. You could imagine this showing up in your admin dashboard. We'll render this partial from our existing index. When we reload the page, we'll see the resolved config for our application. For Jeff, we see that the default value for GDPR banner is true, but the evaluated value is false. That's because he's in the US. Swapping to Tony shows us the default value of true and the evaluated value of true. When you change a value in Prefab, it pushes out the changes to your Rails app. We can use Turbo in Rails to see these updates in real time. As a trivial example, we've added a Prefab live config to our Prefab values template. It returns a blank string by default, but we can use live config to set any class we would like live on this table. In our Prefab UI, let's add a new config. We'll set the value to be text 2XL with font mono, then we'll save and publish. Since we haven't yet wired up our turbo stream, we'll need a reload to see the latest value. After pressing Command R, we see that our classes have been updated. Now let's wire up our turbo stream. In the application config, we will set an onUpdate listener for Prefab to push out a replace to for our Prefab values partial. This will target the ID that we specified in our partial. Next, we need to wire up the turbo stream in our index. Because we changed our application.rb, we need to restart the server once more. We'll refresh the page, and from here on out, we should see our updates in real time. Let's edit this to be text LG instead of 2XL. We'll save and publish, and the update takes place immediately. Now instead of white and blue zebra stripes, let's change the white background to be yellow. We'll do BG, yellow 50, and save and publish again. Perfect. You've seen how easy it is to add Prefab to a Rails app. With dynamic log levels, feature flags, and live config, you can take control of your app's behavior like never before. Visit prefab.cloud and get started today.